Good morning, students. Right. So, yes. So again, we came back with the theories portion, right? As we know already, we have done a lot of numericals with you. I think these numericals are also very important. As you know, in class 12, this from the beginning, that is in the first part of your NCERT book, in the 7 chapters, right? I think there will be no decrease in the syllabus from these chapters at least, right? So be careful and please try to do these all the chapters, right? Yes, it is mandatory and they all are very important parts. Is it clear? And in these 7 chapters you will find, right, lot of questions will be there from which the conceptual can be formed. Is it right? The conceptual question I am talking about. So before that, let me come again with the theory portions. So last day, I think in the last video we have done with the carbon resistor, you know that, right? A carbon resistor which is very useful. Is it right? For what? A carbon resistor which is very useful to find the resistance value and even the tolerance also. So let me know now, is it right? If you have suppose 3 5 ohm resistor, is it right? Whereas in my circuit requirement is 15, or suppose 2.5, or maybe it is 3 less than individual, then how can we combine them to get the answer? This is actually the topic called combination. अगर हमारे पास रिक्वायर्ड रेसिस्टर या रेसिस्टेंस नहीं है तो हम इसको कैसे बना सकते हैं? तो विद द हेल्प ऑफ द कम्बिनेशन, एंड देयर आर टू टाइप्स ऑफ कम्बिनेशंस, वन वी कॉल सीरीज, अनदर इज पैरेलल. क्लास 10 में ऑलरेडी तुम कर चुके हो, मैं उसमें फिर से हाईलाइट कर देता हूँ थोड़ा सा. सीरीज मीन्स वेरी सिंपल, कीप इट इन माइंड, क्योंकि ये जब तुम्हारा क्वेश्चन आएगा वो मिक्स्ड में रहेगा, तो उसको मिक्स्ड में कैसे सॉल्व करना है. So series means very simple. Suppose here I take R1, R2, R3. This is a symbol of a resistor. You know that, right? So if one resistor is connected with the one terminal of the source, and second one is connected with the first one, and third one is connected with the second one, and ultimately the third is also connected with the source, then only we can say the three are in series. Once again, first terminal of the source with the first resistor and second with the end of the 3, or maybe in between 4, maybe in between 5. Is it right? इसको हम लोग series बोलते हैं. In series what happens, the current I is passing from the source and there is no way to pass the current. सिर्फ एक ही रास्ता है, तो इसीलिए R1, R2, R3 में एक ही current आएगा, I. Is it clear? These all are the comma only here I have given. Is it clear? Don't get puzzled. है ना? एंड आफ्टर दैट इफ V इज द पोटेंशियल, सपोज 10 वोल्ट है, तो इसमें 10 वोल्ट में कैसे होता है, मैं तुमको रफली दिखाता हूँ. 10 वोल्ट में क्या होता है कि वी नो दैट इन बिटवीन और इन द रेसिस्टर R1 देयर इज अ कॉल पोटेंशियल ड्रॉप, कहते हैं इसको, क्या बोलते हैं? पोटेंशियल ड्रॉप. राइट इट ऑल्सो. हाँ, दिस पोटेंशियल ड्रॉप अनदर नेम इज कॉल्ड पोटेंशियल डिफरेंस. क्यों? बिटवीन दिस टर्मिनल एंड दिस टर्मिनल सम पोटेंशियल विल बी ड्रॉप एंड दैट इज कॉल्ड द पोटेंशियल डिफरेंस. Similarly, here in between there is a potential drop and in between there is a potential drop. So suppose, for example, the potential is my 10 volt, then 10 is the difference between the positive and negative. Is it clear? 10 is the difference between the positive and negative. So that means positive will always have a higher potential. तो higher मतलब, तो difference अगर 10 आ रहा है तो मैं ले लेता हूँ इसमें 10 और ये टर्मिनल हो गया नेगेटिव का मतलब 0. तो ये 10 हो गया, that means this is also 10. This is 0 means it is 0. And suppose R1 is dropping suppose 6 volt. तो 10 minus 6 कितना हो गया? 4. That means यहाँ पे आ जाएगा 4 points में. And suppose here it is dropping is suppose 3. तो 4 minus 3 is here it is 1. And definitely 1 minus 0 is 1. So it will be 1. 6 plus 3 9 and 1 10. So in this way we can say the summation of all the potential in the resistor is equal to the total potential. देखो V1 plus V2 plus V3. Is it right? By Ohm's law, V is equal to Ri. This is also Ri. This is also Ri. This is also Ri. But since it is V3 indicate for the R3, so I will write R3I. It is R2I. It is R1I. In this way I will get the answer. इस तरह से हमको आंसर मिल जाएगा रेसिस्टेंस का combination in series. Similarly, in parallel what happened? This is R1, R2, R3. Parallel means one terminal is connected with R3 also, R2 also, R1 also. इसको कहते हैं parallel. But from one side, from another side also, the negative terminal is also connected with the 3 resistors. Then only it is called parallel. Otherwise not. Okay, चलो ये हो गया. Now, what happened to the current? Current जब pass कर रहा है, इसके बाद उसको तीन रास्ता मिल जा रहा है. यहाँ पे एक ही था देखो. But here 3 ways are there. 1, 2 and 3. That's why let me write I1, I2 and I3. They may not be similar. Similar भी हो सकता है. Depends upon the resistor. Clear? अगर resistor same होगा तो definitely you will say the current will also distribute in the similar way. Is it clear? Okay, आगे. And according to the Ohm's law तुमको पता है कि current and resistor हमेशा क्या होता है? Inversely related रहता है. Okay. Now come here. This I, that's why I have written here, the total I which is passed from the source is the distribution of all the currents in the resistors. This is the way of writing. According to Ohm's law, we know it is V by I, V by R, V by R, V by R. Since it is 3, so R3, 2, R2, 1, R1. This is the total one. Total means source. Keep it in mind. तो इस तरह से इस तरह का फॉर्मूला मिल जाएगा तुमको. 1 by R1 plus 1 by R2 plus 1 by R3 is the what? Definitely formula of the resistance. चलो आगे क्या करेंगे. एक और चीज तुमको मिल गया, conclusions. The conclusion is this. Here total resistance है ना, ये जो तुम्हारा total resistance है, total resistance is what? less than any what? individual R1, R2, R3, कोई भी any individual less than any individual resistance. For example, this is 5, 3, 2. Less is 2. So your answer will be less than 2. Yes, is it clear? Whereas in the series, you get that total resistance. Let me write here. यहाँ पे अगर तुम्हारे पास maybe it is visible or not. Is it right? Yes, little bit it is visible. So let me write this here. Here, is it right? Total resistance. So total resistance in series is greater than any individual what? Resistance. Is it clear? So it is visible, I think. Yeah, it's a little small, थोड़ा adjust कर लेना. Total resistance in series is greater than any individual resistance, where in parallel it is less. मतलब if it is 5, 3 and 2, greater is the 5, so answer will be more than 5. This is the range of giving the answer. Is it clear? Okay, thank you. So the next topic is the internal resistance, right? So this is another topic in your portions of current electricity. Internal resistance, this is the symbol of internal resistance, small r, you can see, and this is called a cell, right? So it means a resistance provided by the solution of a cell. Solution, हम solution को क्या बोलते हैं? We say solution is called the electrolyte. You know, in the chemistry already you have done in the electrolysis process. Is it clear? Electrolyte is called the solution and the plates are called electrode. Is it right? Yes. So inside the cell there is only solution. There is no any resistor. Is it right? Who will provide the resistance? But this solution will also provide, is it right, hindrance for the flow of current. वो भी तुम्हारा थोड़ा बहुत क्या करते हैं, रोकते हैं. जैसे तुम्हारा similar the way inside the wire or any metal, when there is a resistance and you know why, is it right, you know well what is resistance. Resistance means the flow of, जब भी तुम्हारा इलेक्ट्रॉन फ्लो करता है तो फ्लो ऑफ इलेक्ट्रॉन्स को क्या करते हैं, there is a what, hindrance, or they try to stop them to flow because of the number of collisions. Yes, so here also they are try to stop, and that is called internal resistance. So inside the cell you will get one internal resistance. Internal resistance depends upon the number one concentration. इसका concentration में depend करेगा. Electrolyte का separation between the electrode, इन दोनों का distance कितना है, area of immersed portion of the electrode, कितना अंदर में डाला गया है area, and the nature of the electrolyte. So these four are very important points. Out of this in board, maybe in 2018 or 17 they have already asked in which criteria the internal resistance depends. So you have to give this answer. Is it right? Very important. Keep it in mind. Internal resistance and external resistance are always connected in series. Let me say the example is this. अगर ये external है और ये internal ये cell के अंदर है, तो they are always connected in what? Series. Keep it in mind. So total resistance here it is R plus small r. You can write if I'll ask you what is the total resistance, and if internal is not given, so don't mention about it, है ना? नहीं दिएगा तो तुम सिर्फ external को count करोगे. But if you'll give, then you have to count that also. Total potential is E. अब तुम बोलोगे सर टोटल पोटेंशियल हम लोग सिर्फ V में लिखते हैं. नो, वी कैन राइट एक्चुअली द टोटल पोटेंशियल इज कॉल्ड E. E का मतलब होता है EMF. EMF मीन्स इलेक्ट्रोमोटिव फोर्स. And what is this electromotive force? Let me discuss about this. Is it clear? Thank you. Now you can see what is the difference between the EMF and the potential difference. Internal resistance खत्म हो गया. अब इसके बारे में सोचो. EMF, as I told you, it is called known as electromotive force. But what is the meaning of this? EMF is the total potential supplied by any source. Like this. The source which is supplied the potential, the total potential supplied by the source is known as the EMF. Is it right? When we measure this EMF, when the circuit is what? Open. Is it right? You can write total source, right? You can write or add when circuit is open. Open means if I'll take a cell, is it right? And if I'll open means not connected. And suppose with the help of voltmeter if I'll measure, then I will get his total source. यहाँ कोई resistance नहीं है तो ये अगर 10 वोल्ट है ये तो 10 ही दिखाएगा. This is called open circuit. And when we connect it with a resistor, then it is called the closed circuit. Is it right? So now listen everybody here. So EMF तो समझ में आ गया तुमको, टोटल सप्लाइड हो रहा है. टर्मिनल पोटेंशियल क्या है? V. This terminal potential is only get when it is also known as potential difference. When इसमें ऐड कर देता हूँ, when circuit is closed. So keep it in mind, when your circuit is closed, then only it is connected with a resistor. वो भी external. Internal तो रहता ही है. So what happened here? When the circuit is open, here internal is not working. Mind में रखो. और जब तुम्हारा सर्किट क्लोज रहेगा तो look at here, the current I is passing from here. External में भी पास किया और फिर internal में भी पास किया. Since there is only one way, so I in external also and in internal also. Is it right? कोई प्रॉब्लम होगा तो तुम व्हाट्सएप में भेज सकते हो मेरे को. क्लियर इट इज. नाउ लुक एट हियर. दैट्स व्हाई वी कैन से, अब देखो इसमें गौर से, अगर मान लो कि ये मेरा 10 वोल्ट है, माई EMF इज 10 वोल्ट, एंड वी नो दैट कि दो रेसिस्टर है तो दोनों में तो पोटेंशियल ड्रॉप करेगा, वो भी सीरीज में है तो पोटेंशियल्स तो ऐड ही होंगे ना. जितने भी पोटेंशियल इसमें ड्रॉप होगा और इसमें विल टोटल इक्वल टू द टोटल 10. Suppose here it is dropping is 6 volt. Is it right? That's why here it will be dropping will be 4 volt. Total 6 and 4 will be 10. Or mostly internal में बहुत ही कम dropping होता है. Let me say 1 volt, then the 9 volt will be there. So is it right? So I think 9 volt is called potential difference and this 10 is called EMF and 1 volt is the potential drop in the internal resistance. And you know what are the factors, depends on internal. Okay, now the relation. If you come with the relation between the EMF and the potential difference, it's very simple. देखो 10 9 1. So here I have written 10 is equal to 9 plus 1. This 1 is what? Potential. And you know potential formula क्या हो गया Ohm's law के हिसाब से? V equal to RI. R ये small r, I. That's why I've written V. नाम अलग अलग है. EMF, potential difference and potential in the internal. This is the relations between the EMF and potential. ये भी बहुत important relation है. Now let me find the relation between the EMF and R. Or sometime they asked, right, the equation of or the formula of internal resistance. ये भी पूछते हैं तुमसे. So how we can find the equation of the internal resistance? We know this is a relation, take it from here. Is it right? After that, what is I? I तो total है ना. I is called the total current. कहीं वो distribute नहीं हुआ. So total current is always total. According to Ohm's law, I is equal to V by R. So if it is total, then potential will be total. So total potential को हम लोग क्या बोलते हैं? EMF. So it is E divided by total resistance R plus small r. Now put it here in the equation number 1. डाल दिया, इसको LCM कर लो. Is it right? You will get this. After that you will get a relation. ये भी बहुत ही important है, ये बाद में मेरे को काम लगेगा. So keep it in mind. This small r you can find, which is hidden in the inside the battery with the help of EMF, potential difference, and external resistance. Yes. Now if you have any problem you can ask. तो ये चीज़ हमको समझ में आ गया क्या? EMF always greater and potential difference is less. Is it clear? तो अगर मान लो कि एक सर्किट में तुमने लगाया और एक वोल्टमीटर लिया, if you take a voltmeter and if you connect it with this, is it right? And suppose voltmeter is showing 9 volt, then what is the reason of 9 volt? It means one is dropped inside the internal resistance. Is it clear? Yes, thank you.